I'm sorry for the silence. So let's start today with one of the key components when you are doing a migration. So that is the AWS Storage Gateway. So for the Solution Architect Professional exam, you need to know a Storage Gateway in depth. So a storage gateway is going to be a bridge between your on-premise data and your cloud data in S3. And the use cases are going to be to do disaster recovery, a backup, and restore or tiered storage. So there are the four types of a storage gateway we are going to see there. We have the file gateway, we have the volume gateway, tape gateway, and then we have the Amazon FSx file gateway. So which is another kind of the file gateway. So the storage gateway has an interface and saves that file into Amazon EBS, S3, and Glacier. So the Glacier is being hidden by me. Just let me show you that. So this is the Glacier. But we'll see that in details in these lectures and this lecture. And so for the exam, you absolutely need to know them, the difference between them, and all the four types of storage gateway. So let's have a go right now. Okay, let's get started. So file gateway, we'll be seeing first of all the file gateway. So file gateway is going to be one receiving the most attention in this lecture because it is something you have to understand. It opens up a lot of different architectures that we are going to see in this lecture. So with file gateway, you are going to get a virtual appliance, a virtual machine. So that is going to be a bridge between your network file system NFS and Amazon S3. So let's have an example here. On your on-premise data center, you are going to create a file gateway appliance. This is a virtual machine, and then it's going to open up a file share you are going to open a file share in the form of the NFS network file system and SMB protocol, and your servers are going to connect to that file share. And in the backend, your file gateway appliance is going to translate that into storing some information onto an S3 bucket in your AWS cloud. So the metadata and the directory structure are preserved with this. The configured S3 buckets will be accessible both using the NFS and SMB protocol. And you have to remember this going into the exam that the bucket access using the IAM roles and each file gateway should have an IAM role to access Amazon S3. And that makes a lot of sense here because it's going to be a virtual machine accessing a AWS service. The most recently used data is going to be cached in the file gateway. So this allows your file share application to talk to file gateway and talk to the cache. So it doesn't proxy every request to Amazon S3, and that allows for like the better performance. And as I said earlier, that it could be mounted on many servers. So a ton of your servers on-premise can have your NFS or SMB protocol to talk to your file gateway appliance. So there's one paper that I find extremely like interesting to read. If you wanted to, like I've been included the link there, which shows some architecture using the file gateway. And I have extracted the most important ones that I think that are really useful for you to show this in this lecture. So let's take an example. Here our server is going to have a file system to connect to. And we'll have we have to store multiple files. And so as you can see in this example, there's a directory structure on your files here, and this is going to translate right away to the files into your S3 bucket in your bucket name, as you can as you'll be able to see that now. So it's very simple. This is intuitive, and this is something we would expect with a file gateway. So next, what we can do like with the file gateway. So here is some interesting thing to think about when you are a solution architect. So our traditional server can access our file gateway appliance on premise using the NFS and SMB protocol. And as we said, the files are going to be stored in the backend into Amazon S3. Now it is 100% for you possible to use a VPC and create another file gateway appliance and connect your EC2 instances over the NFS and SMB. And why would you do this? Because like maybe you want your EC2 instances to access Amazon S3 as a file system, and therefore you are going to use a file gateway appliance for that. So this could also be a way for you to migrate your application from on-premise to the cloud using the same protocol, the same NFS or SMB protocol, and it would be first step to move your workloads into the cloud. But once the data is in Amazon S3, remember every single file is going to be in Amazon S3, and then you can use S3 events to send that information to Lambda, and then Lambda functions maybe process some of these objects for you, or like we can use Athena to query all of our data in Amazon S3. The beautiful thing is that the Athena only uses the resources of Amazon S3, and so it doesn't impact the performance of our file gateway. And we can use a Redshift spectrum or even the EMR to analyze the data. Finally, we are able to use cross-region replication, cross-region, for example, to back up the data into another region for disaster recovery purposes. So by using the file gateway, it seems very simple. We are exposing a network file system to our corporate data center, but because the data appears to be in S3, at the end, it opens up many different possibilities, and I hope you can see this from from this diagram. Next, we could have read-only replicas. So for example, you wanted to replicate a file system from one on-premise data center to another on-premise data center. In the first on-premise data center, you would create your file gateway appliance number 1, and your applications would write some files into it, and then you would appear in Amazon S3, and you would appear in Amazon. And in another on-premise data center, you can create a read-only replica so that your file system, your application servers, and can read a read-only copy of your file gateway appliances, and to get the data first with lowest latency. So this is yet to another architecture you have to think about when you are using your file gateway appliances. And next, there's a way to do backup and lifecycle policies. So let's take an example. Our application servers are talking to our file system on the file gateway, and the files are going to be backed up into Amazon S3. But it is possible for these files to be used less and less, and so we can define S3 lifecycle policies, maybe to migrate stuff to Amazon S3, standard IA first, and for frequent access, and then after a while migrate it to Amazon S3 Glacier. So what we have done is that effectively we have made sure that we are getting some cost savings for our file system on top of getting an NFS interface for our application server on premise. So yet another thing to think about this is, this is Amazon S3. Now, here, so we have so many other possibilities. The first one is that if you do enable Amazon S3 object versioning, then you can store multiple object versions as they are modified, which is extremely helpful if one of your engineers or one of your employees is asking you to restore a specific file to a previous version, because you are restoring every single change in Amazon S3. It is definitely possible for you to restore any file to any previous version, or you can even restore an entire file system to a previous version. But if you do so, to restore a file or a file system to a previous version, you need to let your file gateway appliance know that there has been a change, and so there is a refresh cache API on the gateway, so that you notify the gateway that there has been some restore happening, some changes happening on the Amazon S3 buckets, and there will be a synchronization happening in the backend. And another one is to use Amazon S3 object lock, and this enables the file gateway to be write one and read many. So a warm write one, read many, okay, and data network file system, that's what file gateway to be, a write one, read many, so warm data network file system. So the idea is that if there are any modification or renames in the file share client, the file gateway will create a new version of the object without affecting prior versions, and the original locked version will remain unchanged, effectively making sure that you are not losing any data, and that the original data will never be deleted in such case. So for like compliance reasons or audits or to restore again versions and reasons, this could be really helpful. So that's all for the file gateway. Now let's go over quickly over the volume gateway and the tape gateway. Okay, so volume gateway is going to give you a block storage that will be using the ISCSI protocol, and ISCSI protocol will be backed by the Amazon S3, and this gives you two kind of volume gateway. The first one is cached volume to give you low latency access on premise to the most recent data, while the full data set is going to be on S3. Okay, so case volume cached volume makes sense like so cache volume will make sense when by volume, what I mean, for example, like if you have an EBS drive attached to one of your EC2 instances, that is a volume. So this is the same concept, but on premise using ISCSI protocol, the other option is to use a stored volume in which the cache is the entire data set is going to be on premise, and then there will be a scheduled backups to Amazon S3 for that volume. Why for as of the I mentioned the EBS in the earlier. Why I mentioned that? Because if your on-premise system have access to a volume on-premise, but then it is backed up into S3, and you can create then EBS snapshots from the volumes and restore them as EBS volume. So we have another we have to remember here is that the files within the volumes are not accessible directly in S3. The only way for you to retrieve a file from a cached volume or a stored volume is to create a EBS volume out of the EBS snapshots of these volumes, and then from the EBS volume that you have created, you can retrieve the file you want. So what do we get here? We get up to 32 volumes per gateway, and so each volume will get up to 32 terabytes in size. Each volume will get up to 32 terabyte in size in cache mode. So that gives you 1 petabyte per gateway. 1 petabyte per gateway, yeah, I'm right. Or each volume can be up to 16 terabyte in stored mode, and that gives you about half a petabyte per gateway, like the 512 terabyte per gateway. So as a diagram, what does it look like? So here, our application server are on premise, and they talk using the ISCSI protocol to our volume gateway. Volume gateway which exposes volume for your application servers, and in the backend there's going to be a synchronization done with the Amazon S3 over HTTPS and so securely. And then if you wanted to retrieve the data in the and analyze it as EBS volume to look at the individual files. So for volume gateway, remember, like the cached volume means that the most recent data is cached and on premise, but all of it is going to be on S3 for a stored volume. The entire data is on the on premise, and there will be scheduled backups to S3, and this is the volume gateway. And then finally we have tape gateway. So some companies have a backup process that backup process that actually involves using physical tapes, and so with tape gateway companies will use the same process, but this time in the cloud. So what we'll have in that is that we'll have a virtual tape library or VTL that is going to be backed by Amazon S3 or Glacier, so we can use them. We can use the same software from before, the same process from before, and have them directly be put into the AWS. So this works with like leading backup software vendors, but the idea is that these tapes, once they are in Amazon S3, you cannot access files within these tapes. You would need to restore the tape entirely to access the file. So this is a common pitfall that the exam will try to test you on, like on using the tape gateway or the volume gateway. You would need to restore the tape or the volume entirely to access a single file, whereas with the file gateway, every single file is going to be exposed in S3, which makes it accessible for your application. So here is a sample diagram given below. Our backup server adds an ISCSI interface to our tape gateway. And this is our software. This is going to take regular backups, and the tape gateway will be configured to send all these types to tapes to Amazon S3 for Glacier for archival purposes. And again, if you need to use these tapes and the data within them, you would need to first restore the tapes entirely, and then you would have access to the data. And finally, we have Amazon FSX file gateway. So Amazon FSX file gateway, which gives you native access to Amazon FSX for Windows file server. Okay, remember this, like it has a local cache for frequently accessed data, and it has a Windows native compatibility over the SMB protocol. So NTFS or Active Directory, it's a very useful when you want to group files, shares, and home directories. So the architecture is that you will be running Amazon FSX for Windows file server on the AWS cloud, but you want to access it from your corporate data center. So you would create an Amazon FSX file gateway so that your SMB client can access the cloud directly. Okay, so you have more information you need for the storage gateway regarding the solution, even the architect professional for the even the architecture professional exam. So this is the Amazon FSX file gateway, and this is it for this lecture, and I hope you liked it, and I'll see you in the next one.